Welcome to Unit 1, Lesson 6, Conditional Probability. So, what is the probability that the test market is selected in the East? So we notice that we have a total of 125 and the total for the East specifically is 75. That makes the probability of it being in the East 75 out of 125. The probability that the test market selected is in the West. The probability for the West, that total is 50 out of 125. Not to confuse the U with our OR symbol, let's change this U to a C. So we'll refer to C for urban. Think city. So the probability of it being urban is going to be 45 out of 125. And the probability of it being rural is going to be 80 out of 125. So those should all be fairly simple, just reading the table. Now, what is the probability that the market is western and rural? So if we look at the table for western and rural, we should see 30 out of 125. So now, the probability for eastern or urban, we can use our addition rule. So the probability of eastern plus the probability of urban minus the probability of eastern and urban. So if you add up those numbers for the east of 75 plus 45 minus eastern and urban, so minus 25, that's going to give us 95 and still out of 125. Okay, so now, whenever we have a question in reference to independence, remember we are using our multiplication rule. So let's still use eastern and urban. So if we look at, we want to see if the probability that it's eastern times the probability that it's urban is equal to the probability of eastern and urban. So in this case, we're looking to see if 75 over 125 times 45 over 125 is equal to 25 over 125. So when you do the math, you see that it is not equal. Therefore, it is not independent. So before we get to H, in terms of our probability that if an area is in the East, it is urban, let's first look at our conditional probability formula. So the slash would represent the probability that A will occur given B. So whatever's on the back end is your given. So that probability is what you're dividing by. So we have the probability of A given B equals the probability of A and B divided by the probability of B. So this is your and divided by your given. Okay? So if we look at this example, going back to your first page, and we have the probability of it being urban given that it's in the east. So we're going to look at it mathematically and simply by looking at the table. So if we simply look at the table, then we are only going to look at the row for the east. And we see that that total is out of 1 out of 75. So the probability that it's urban now is 25, and the total for the east is 75. So we get 25 out of 75. So we can also figure that out using our formula. Probability of it being urban given it's eastern is going to be equal to the probability of being eastern and urban, and it doesn't matter which one comes first when it comes to the and, divided by the probability that it's eastern. Again, whatever your given is, that's what you're going to divide by. So we have two quotients, one being 25 over 125, and the other being 75 over 125. So remember, if I'm doing 25 over 125 divided by 75 over 125, then I have to flip and multiply so that this becomes, instead of divided by, times 125 over 75. So obviously I can cross 125 out, and I end up with my 25 over 75. Okay, which is the same thing we got when we looked at the table. So if we look at the second example, or the first example on the second page, if I'm looking at the probability of A given me, the probability of A and B over the probability of B is equal to 0.25 over 0.4, which becomes 0.625. Next example, we have a Venn diagram. Given A is 0.35, B is 0.4, and the AND is 0.2. So this becomes 0.2. This becomes 0.15. This becomes 0.1. So notice the total for A is 0.35. The total for B, actually, it should be 0.2. The total for B is 0.4, which leaves me with 0.45 here. So, are A and B mutually exclusive? I know that that answer is no, because the probability of A and B does not equal 0. What is the probability of A or B? So I can do a couple different things. I can add up those three values, or using my addition rule, the probability of A plus the probability of B minus the probability of A and B will give me 0.55. Now, conditional probability. It's going to be equal to the probability of A and B divided by the probability of B. That's going to give me 0.2 over 0.4, which is 0.5. Again, anytime you have a question of independence, you're going to use the multiplication rule. So we're going to have the probability of A times the probability of B, and we want to know if it's equal to the probability of A and B. So when we do that, it's 0.35 times 0.4, is that equal 0.2, which it is not, so it is not independent. Okay, so let's look at our next example. You have a table of 500 individuals grouped, and they were classified into 3 different groups. So what is the probability that a person is selected at random from the group? Find the probability that he or she is in age group 3. Again, looking at the table. So that's just 150 over 500. That their pressure is above 90. That's 170 over 500. And C, that they're from group 1 and their pressure is below 70. So that is, looking at the table, 20 out of 500. D, that they're from group 1 or their pressure is above 90. So remember with the or, we're going to use the addition rule. So we want the probability that they're from group 1 plus the probability that the pressure is greater than 90 minus the probability that they're from group 1 and their pressure is greater than 90. So that's going to be 250 all over 500. So for group 1, you had 100, pressures above 90. You had 170 minus 20 gives you your 250. So now E, we have a conditional probability. So we want the probability that they're in group 2, given that their pressure is less than 70. So the probability of being in group 2 and pressure is less than 70 over the probability that their pressure is less than 70. So you can look at the table. After giving, the pressure is below 70. So you're only going to look at that row. So the probability that they are in group 2 is 30. And that brings it to 30 over 70. In F, you have the probability that they are between 70 and 90, given that they're in group 3. So the probability that they are between 70 and 90 and in group 3 divided by the probability that they are in group 3. So again, the given is group 3. So if we're looking at the table, we're only going to look at this column. So between 70 and 90, that puts the blood pressure at 60. So our answer is going to be 60 over 150. Okay. For the last page of the notes, make sure you check out part 2 of our conditional probability. Make sure you stop the video and rewind if you need to go back or if you miss something. Thank you.